Good afternoon, class. What I'm going to do for you today is section 6.3, problems 1 through 3. Those problems that were given to you for homework from section 6.3. Let's go to work. Only problems you had to do were numbers 1, 2, and 3. And basically what we're doing here is we are trying to create equations for the following situations. When we're doing these, one of our favorite forms, well, we have to remember our forms. We got standard form. Let's try that again. Standard form. I'm going to lose the form. Standard is ax squared plus bx plus c. We got intercept form, aka factored form, which is ax minus p times x minus q, and we got vertex form. Vertex may end up being the one we use the most, which is a times x minus h quantity squared plus k. On this first one, that's exactly what I'm going to use here. Is I'm going to use my vertex form. So if I plug that into vertex form, I've got a times x plus 3. Remember, it's always the opposite of x squared plus 4. Now, I know this 0 is the point 3, 0. So now I can plug those values in to this equation. So I have 0 equals a, parenthesis, 3 plus 3, quantity squared, plus 4. Well, 3 plus 3 is, and now I'm going to solve for a. So 3 plus 3 is 6. 6 squared is 36. So I have 36a plus 4 minus 4 minus 4. I have a negative 4 equals 36a. Divide by 36, divide by 36. So a equals a negative, 4 goes into 36 9 times, so negative 1/9. So my equation then is y, or f of x, equals negative 1/9 quantity x plus 3 squared plus 4. In my second equation, I'm going to do the same thing. I got to start by finding my vertex. Remember how we talked about in class, we're looking for the y values that match. Those match, and those match. Since they match, this must be my vertex. So I'm going to take that vertex and, I don't know, I'll choose this point, my x's and my y's. So y equals a times, I would use x minus 4, but I'm going to plug in that 2, so 2 minus 4, quantity squared. You know what, I'm going to take my time since you guys are at home, and I'm going to do it step by step. Let me plug these values, because that's my vertex, in first. So x minus 4, so that 4 goes in there, quantity squared, minus 7. So now I'll take this x and y and plug them in there and there. Okay. So I now have 1 equals a times 2 minus 4, quantity squared, minus 7. Well, 2 minus 4 is a negative 2. Negative 2 squared is 4, so that's 4a. So 1 equals 4a minus 7. Add 7 to both sides. 8 equals 4a. Divide by 4. 2 equals a. So my equation, this a, goes back into that equation now. So I have y equals 2. X minus 4, quantity squared, minus 7. There's the equation in my line. I created that from the table. Last one over here. Here is my vertex, and I'm going to cheat a little bit. I'm going to use some knowledge I have. There's my vertex. Okay, and I need a couple more lattice points. There's one, and there's one. So starting off, I have y equals a, parenthesis, x plus 7, quantity squared, plus 5, because this point right here is -7, 5. So I got to do the opposite of the x plus the k, or plus the y. Now, what I'm supposed to do now is I'm supposed to take one of these other 2 points, like this one is -6, 3, or this one over here, which is -8, 3, and I'm supposed to plug those in for the x and the y. But remember, way back when we were graphing, I talked about that first point being one value to the right or one value to the left as being the a value. So from this vertex, I can go down 2 and over 1. So my a is actually a -2. So that's using a shortcut and some of the knowledge that we already have. X plus 7, quantity squared, plus 5. So I kind of cheated there a little bit and used some knowledge that we already used this year instead of plugging in those values in. But if I put those values in, you would have got -2 as well. So there's your answers for numbers 1, 2, and 3 from section 6.3. I hope that's helpful for you. If you have questions, please post those questions on our Google Classroom, which is where we're going to do a lot of talking and discussions in the near future. Herman out.